Video report on my progress for making a pump, a pump controller. Unfortunately, it did not go well. Turns out that the little stepper driver module, see the thing in here, this thing here, it requires a lot of current to drive it. A lot of current. And so that confuses the level translator. So I can correct for that by using a buffer, which is this little thing here. However, the little buffer thing cannot supply enough current to drive the motor driver. And I can see that on the oscilloscope because the voltage does not rise to a level that's sufficiently high to drive the driver. So it doesn't go past about 3 volts, which is not enough. So this is basically the problem with interfacing the circuitry and the quality of the circuitry. And to some degree my own lack of experience in this exact thing. This is kind of similar to the problem we had with the motor drivers, where the inputs were not standard logic inputs, they weren't high quality devices, because the logic input is not supposed to have a high impedance, it's not supposed to source or sink very much current. But sometimes tuned devices do that. And the other two inputs are fine, but the pulse input is the one that's giving me problems. And yeah, so we just can't give it enough current. We need a little amplifier or something to give it enough current. A buffer, a high current buffer of some kind would probably work fine. But we need more stuff for that. So I don't really know where to take it at this point. I can buy more stuff, buy. Or we can return this pump here, get our $80 back, then use the pump we have. We'll just scooch our expectations down. We're not going to be able to test the total processing capacity of the system in terms of its rate. We'll be able to prove that it works at some speed, a relatively low speed of processing, in terms of milliliters per minute. As long as the pump doesn't crap out on us, the pump we have, it might get clogged or something, it's possible. So yeah, that was not a waste of time, but it was not a good use of time. And it's a lesson in the importance of buying good quality stuff from the beginning. Good quality general purpose stuff that you can do all kinds of things with, not just stuff that's made for a very specific purpose. This control board is the one that came with this pump, and it's capable of driving the current through the interface here. However, it has this weird thing where you turn it on and it runs for 30 seconds and then it turns off by itself. And it just always does that. So it works, but you have to stand there and press the pump once every 30 seconds. Well, that's an idea. I could just use an Arduino to basically do the equivalent of pressing the button every 30 seconds. And that would be pretty practical and easy, and I wouldn't have to buy any new stuff. So I could reassemble this thing and just do that. Yeah, maybe that's a reasonable approach. We could just keep the pump for now, but we can return it later on if we don't use it. But we'll take it with me to Montreal. That way we have a backup pump system. Because the tubes fit and everything. The tubes fit on those little connectors there. I tested the tubes and measured the pumping rate. It's pretty good. It's 480 milliliters per minute, which is pretty good. And it otherwise works great. So I'd hate to just return it without using it. If it's not going to cost us anything, we might as well bring it to Montreal and see if we can put it to use in a pinch. Of course, if we use it, we're going to have to clean it out before we can return it. But we could do that, probably. So yeah, that's probably a good strategy. Just takes a little thinking. How am I going to make it so that the button gets pressed? I could just use a servo to actually physically press the button. Or I could use a solid-state relay. I don't know. I'm going to have to think about that one.